In this video, we are going to be looking at proving trigonometric identities. And the idea of an identity is that it does not matter what values you put in for the variables, it will always be true. That isn't the way that all equations work, right? It's easy to come up with examples of equations. For example, here's a simple equation. Say 3x plus 2 is equal to 2x plus 1. This is an equation, and there is a value of x that we can put into both sides and it will become true, but it won't work for all values of x. For example, if I put a 0 in here and I put a 0 in there, it would say 2 equals 1, and that's not true. It's not true for every value of x, so this is an equation, but it's not an identity. Let's prove that this actually is an identity. In other words, the left-hand side is just another way of writing the right-hand side. A very good idea when you're working on proving identities is to change things back into sines and cosines. So the tangent of theta is the same thing as the sine of theta over the cosine of theta. And a cosecant of theta, that's just the same thing as 1 over the sine of theta. Notice how I'm working entirely on the left-hand side. It's okay to work on both sides, but you cannot work across the equal sign as if it was actually an equation. We don't know if it's an equation. That's kind of what we're trying to prove. So, after you change the tangent of theta into the sine of theta over the cosine of theta, times the cosecant of theta is the same thing as 1 over the sine of theta. These sine thetas cancel out. We end up with a 1 on top over the cosine of theta, and 1 over the cosine of theta is just another way of writing the secant of theta, which is what we were aiming for. So the secant of theta is equal to the secant of theta, and this is a successful proof.